For this particular problem, you are asked to solve the systems of equations algebraically. So there is a way to do this using a graphing calculator, but on your test they require you to show your work and do it algebraically. So just to get an idea of what this looks at, let's forget about these equations for a second. Let's just think about parabolas. If I told you that parabolas, two parabolas, intersected at one point, then here's an idea of where they can intersect at one point. They touched at just one point, so it has one solution. Now that solution has both an x and a y value, correct? If I told you they intersected at two places, it may look like this. So there's one intersection point, and here's the next. This has an x and a y, and this also has an x and a y. Or maybe they have no solution, so they never intersect. Or they could have infinitely many, and in that case, it's one parabola, and on top is exactly the next. So they're equivalent equations. Okay, so that's what we're finding out today. We're finding out how many solutions, and then really what are these solutions. Remember, every solution has an x and a y coordinate. So here's how we do this. Algebraically, we set these equal to one another. So I write down one, and I set it equal to the other. It doesn't matter which one is on the right or which one's on the left. Then I'm going to choose to combine like terms. And there's no wrong answer. So I can move the three terms on the left to the right, or the three terms on the left to the right. Either one. Vice versa. It could work. I like to do this an easier way, so I like to have the leading coefficient positive. So I'm going to move this over. To move over a negative 7x squared, you're going to add. And when you add 7x squared, they cancel. Same thing, to move a negative 1x, we're going to add. And here I will subtract. These all cancel out. There's nothing left on the right-hand side. I'm going to combine like terms. Okay, the next step is to solve for x. There's three options you have to solve. You can always use the quadratic formula or completing the square. Those will always work. The quickest method, which is solving by factoring, only works when the quadratic equation is factorable, and it's not always going to work. So this is like kind of optional. Sometimes this works and sometimes it's not factorable. We can't use that method. These always work. Now I'm going to first try the factoring method because it's always a quicker method. So 14 times negative 2 is negative 28. If this is factorable, can you come up with two numbers that multiply to give you negative 28 and combine to give you 3? 7 and 4. So it has to be a positive 7 and a negative 4. Then we're going to take the leading coefficient, which is not 1, and we're going to place it underneath each number. Okay, reduce the fractions if possible. And then this tells us that one x value is negative 1/2 and the other is positive 2/7. Now, like I told you up above, every answer, so I have two answers, two x answers, but every x answer has a corresponding y answer. So I'm halfway done. Now you get to look up to the original two equations and you choose which one looks easier to work with for you. There's no wrong answer. I think since this doesn't have a negative, I'm going to choose the second one. So I'm going to write down y equals 7, but instead of having an x, I'm going to leave a parenthesis. So this would have been x squared plus 2, again I'm not going to put an x, minus 1. And I'm going to write it again. And now I'm going to substitute in the x value that I solved for in the previous problem. Now I'm going to grab the calculator and let the calculator do the hard work. So I'm going to plug this in. 7 parentheses, negative 1/2 quantity squared, plus 2 times the quantity negative 1/2, subtract 1. If need be, I'll put the answer back into a fractional form. And this y value that corresponds to x equals -1/2 is -1/4. Written as an ordered pair, this is the first intersection point or solution to solving the system of equations. Okay, going to do the second one in the same fashion. So 7 2/7 quantity squared plus 2 times 2/7 subtract 1. Putting it back into a fraction, y equals 1/7. And so the second intersection point is 2/7 and 1/7. These are the two final answers for this problem.